November 12, 1942. Dawn breaks cold and gray over Richmond, California, casting long shadows across what was once a sleepy bayside town. The air thrums with an impossible energy, the sound of 90,000 workers flooding through the gates of Kaiser Shipyard No. 2. Steam rises from welding torches already blazing in the pre-dawn darkness. The acrid smell of hot metal mingles with salt air from San Francisco Bay. In the heart of the yard, something extraordinary is taking shape. Where yesterday there was only an empty slipway, now the skeletal frame of a cargo ship emerges from clouds of sparks and smoke. Workers swarm over the growing hull like ants building a cathedral. Most of them had never seen a ship before Pearl Harbor. Many had never held a welding torch. Yet their hands move with practiced precision, joining massive steel sections with seams stronger than the metal itself. This is the SS Robert E. Peary, a Liberty ship that will shatter every assumption about what's possible in wartime production. In just 4 days and 15 hours, these workers will launch a 441-foot cargo vessel capable of carrying 10,000 tons across submarine-infested waters. What traditional shipyards accomplished in 8 months, they will complete in less than a week. 3,000 miles away, in the concrete bunkers of German naval headquarters, intelligence officers study their reports with growing confidence. Their calculations are precise, their logic unshakable. America cannot possibly build ships faster than U-boats can sink them. They have no idea they're about to be proven catastrophically wrong. The Atlantic Ocean had become a graveyard. By the autumn of 1942, German U-boats prowled beneath the waves like wolves in an endless hunt, their periscopes cutting silent wakes through waters that had claimed thousands of Allied vessels. The numbers told a story of maritime devastation, iron that chilled even hardened naval officers in London and Washington. In March alone, submarines commanded by Karl Dönitz had sent 95 ships to the bottom, 500,000 tons of desperately needed supplies that would never reach Britain's beleaguered shores. The Battle of the Atlantic was not merely a contest of ships and submarines. It was a race between construction and destruction, between America's industrial might and Germany's underwater fleet. Every cargo vessel that slipped beneath the waves carried with it not just steel and rivets, but the lifeblood of the Allied war effort. Food for Britain's hungry civilians, ammunition for troops in North Africa, aviation fuel for RAF fighters defending English skies, trucks, tanks, and medical supplies, all of it feeding the fish instead of feeding victory. German U-boat commanders had refined their tactics to deadly perfection. They hunted in coordinated wolf packs, surrounding Allied convoys like predators circling wounded prey. A single torpedo could erase months of American factory work in seconds. The mathematics seemed irrefutable. Germany was sinking ships faster than the Allies could replace them. Traditional shipbuilding methods required 200 to 300 days to complete a single cargo vessel. Even working around the clock, American shipyards could not match the pace of destruction. In Berlin, Admiral Dönitz studied his charts with satisfaction. His submarines had sunk over 3,500 merchant vessels since the war began. The tonnage war, as strategists called it, appeared to be tilting in Germany's favor. Intelligence reports from occupied Europe painted a picture of British ports struggling with shortages, civilian morale cracking under the pressure of rationing and bombardment. If current trends continued, Britain would be starved into submission within months. But across the Atlantic, something unprecedented was stirring in the industrial heartland of America. In shipyards from Maine to California, a revolution was beginning that would render German calculations meaningless. The methods that had built ships for centuries were about to be swept aside by innovations so radical that even Allied naval officers struggled to believe the early reports. Welding was replacing riveting, assembly lines were replacing traditional construction, prefabrication was transforming how humanity thought about building vessels for the sea. The Germans had made one critical miscalculation. They had studied American shipbuilding capacity based on peacetime methods and traditional techniques. Their intelligence files were filled with careful assessments of existing shipyards, detailed analyses of construction times, precise calculations of steel production. What they had failed to anticipate was America's capacity for complete industrial transformation. They could not imagine that a nation might reinvent the entire process of shipbuilding in a matter of months. For over a century, ships had been built the same way. Skilled craftsmen laid keels in dry docks, then slowly erected frames and plating using techniques that differed little from methods used in the age of sail. Each vessel was essentially handcrafted, with riveters joining steel plates one by one in a process that demanded both time and extraordinary skill. A traditional shipyard might have a dozen vessels under construction simultaneously, each progressing through months of careful, methodical work. The bottleneck was not just time, it was expertise. Shipbuilding required master craftsmen who had learned their trade over decades. Riveters needed to understand the precise pressure required for each joint. Fitters had to shape steel with an intuitive feel for metal and stress. Naval architects designed each vessel as a unique creation, with blueprints that often existed only in the minds of experienced foremen. This artisanal approach produced magnificent ships, but it could never produce them quickly enough to replace wartime losses. By early 1942, the crisis had reached desperate proportions. British Prime Minister Winston Churchill cabled President Roosevelt with stark warnings about shipping losses. The Royal Navy was losing vessels faster than Britain's shipyards could replace them. American Liberty ships, based on a simple British design, represented an attempt to mass-produce cargo vessels quickly and efficiently. But even these supposedly rapid-build ships were taking months to complete using conventional methods. The first Liberty ship, SS Patrick Henry, had required 245 days from keel laying to launch. While this represented an improvement over traditional construction, it was nowhere near fast enough to offset U-boat successes. At this rate, German submarines would strangle the Atlantic supply lines before American production could catch up. Something had to change, and change dramatically. Enter Henry Kaiser, a construction magnate who had never built a ship in his life. Kaiser had made his fortune constructing dams, bridges, and highways using innovative techniques that emphasized speed and efficiency over traditional craftsmanship. He approached shipbuilding with the eye of an industrial engineer rather than a naval architect. Where others saw centuries of maritime tradition, Kaiser saw opportunities for revolutionary improvement. Kaiser's vision was breathtakingly simple yet radical. Treat shipbuilding like manufacturing automobiles. Break the construction process into component parts that could be prefabricated in multiple locations, then assembled like pieces of a massive industrial puzzle. Replace skilled riveters with semi-skilled welders who could learn their trade in weeks rather than years. Create assembly line workflows that move ships through construction stages with mechanical precision. The traditional shipbuilding establishment reacted with skepticism bordering on horror. Naval architects warned that welded joints would fail under stress. Maritime unions protested the use of inexperienced workers on complex vessels. Navy inspectors questioned whether mass-produced ships could withstand the rigors of ocean warfare. Kaiser's response was characteristically direct. Build the ships first, then prove the critics wrong. The transformation began in 1941 at Kaiser's Richmond shipyards, where 4 massive construction facilities rose from San Francisco Bay Marshland with startling speed. These were not traditional shipyards but industrial factories designed for one purpose, turning raw steel into ocean-going vessels faster than anyone thought possible. The stage was set for a manufacturing revolution that would change the course of the war. The human angle revealed the most remarkable transformation of all. Across America, hundreds of thousands of ordinary people found themselves building ships with no prior maritime experience. Farmers from Iowa learned to weld steel plates. Housewives from Ohio operated massive cranes. Teenagers fresh out of high school assembled engines that would power vessels across submarine-infested waters. This was not just industrial mobilization, it was the democratization of shipbuilding itself. Mary Lou Williams arrived at Kaiser Richmond in the spring of 1942, one of thousands of women who answered the call for workers. She had never seen a welding torch before, but within 3 weeks, she was joining steel sections with joints stronger than the metal itself. The training programs were revolutionary in their simplicity: break complex skills into manageable components, teach workers one technique at a time, then combine those techniques into efficient workflows. Traditional apprenticeships that required years were compressed into intensive courses lasting days or weeks. The workforce reflected America's diversity in ways that peacetime industries had never experienced. African Americans from the rural South worked alongside white farmers from the Midwest. Women performed jobs that had been exclusively male for generations. Recent immigrants brought languages from dozens of countries to the shipyard floors. What united them was not background or experience, but determination to build the vessels that would carry Allied victory across the Atlantic. The technological angle centered on a manufacturing revolution disguised as shipbuilding innovation. Welding replaced riveting as the primary method of joining steel, a change that seemed minor but transformed everything about ship construction. Riveted joints required teams of skilled craftsmen, a heater to warm the rivets, a holder to position them, a driver to set them, a bucker to finish them. Welding required only one person with a torch and the skill to lay a continuous bead of molten metal. Electric arc welding had existed for decades, but Kaiser's yards perfected its application to shipbuilding on an unprecedented scale. Welders could join steel sections in continuous lines rather than individual points. The joints were actually stronger than riveted connections, and they eliminated the weight of thousands of rivets per vessel. More importantly, welding allowed for prefabrication. Large sections could be assembled away from the ship, then lifted into place with massive cranes. The leadership angle focused on Henry Kaiser himself, a man who approached impossible challenges with infectious optimism and industrial pragmatism. Kaiser understood that revolutionary times demanded revolutionary methods. He studied automobile production lines, analyzed manufacturing efficiency, and applied those lessons to shipbuilding with results that astonished even his supporters. Kaiser's philosophy was simple: if something seemed impossible using traditional methods, invent new methods. Kaiser transformed construction schedules by working backwards from desired results. If the Navy needed ships in weeks rather than months, then every aspect of production had to be reimagined. Traditional construction happened sequentially, complete one stage before beginning the next. Kaiser implemented parallel construction, multiple stages happening simultaneously. While workers assembled the hull, others prepared engines, installed electrical systems, and fabricated superstructures. Everything converged in final assembly with choreographed precision. The enemy perspective revealed the magnitude of German intelligence failures. In Berlin, naval strategists based their Atlantic strategy on carefully compiled data about American shipbuilding capacity. Their files contained detailed assessments of existing shipyards, precise calculations of construction times, and thorough analyses of skilled workforce limitations. These assessments were accurate for peacetime conditions and traditional methods. They became catastrophically wrong when America reinvented shipbuilding itself. German intelligence officers had studied Liberty ship construction with professional thoroughness. Their reports noted that early vessels required 200-plus days to complete, confirming their belief that American production could never match U-boat destructive capacity. They tracked steel allocation, monitored shipyard expansion, and analyzed workforce recruitment. What they failed to anticipate was the possibility that Americans might abandon traditional shipbuilding entirely in favor of industrial manufacturing techniques. The industrial angle demonstrated how assembly line principles revolutionized maritime construction. Kaiser organized shipbuilding like automobile production, breaking vessel construction into standardized components that could be manufactured simultaneously. Instead of building ships from the keel up in sequential stages, workers assembled major sections, bow, stern, midsection, superstructure, in parallel workflows that converged in final assembly. Prefabrication transformed construction schedules from linear progression to parallel production. While workers laid the keel for one vessel, others assembled hull sections for the next ship, engines for a third, and superstructures for a fourth. Components arrived at final assembly like parts on an automotive production line, ready for installation with minimal modification. This approach required precise coordination, but eliminated the delays inherent in sequential construction. The strategic angle encompassed the Battle of the Atlantic's shifting mathematics. German U-boat strategy depended on sinking ships faster than Allies could replace them. Admiral Donitz calculated that sustained destruction of 700,000 tons monthly would eventually strangle British supply lines. His submarines achieved this target repeatedly throughout 1942, leading German planners to predict Allied maritime collapse within months. American industrial transformation invalidated these calculations completely. By late 1942, Liberty ship production was accelerating beyond all previous projections. Ships that originally required 8 months now took 8 weeks. Vessels that demanded hundreds of skilled craftsmen now employed thousands of semi-skilled workers trained in weeks rather than years. The tonnage war's mathematics were inverting. America was beginning to build ships faster than Germany could sink them. Kaiser's methods spread throughout American shipbuilding with viral intensity. Techniques perfected in Richmond were implemented in shipyards from Portland to Savannah. Training programs developed for Liberty ships were applied to tankers, cargo vessels, and eventually warships. The revolution that began with one man's refusal to accept traditional limitations was transforming America's entire maritime industrial capacity. The implications extended beyond immediate wartime needs. American shipbuilding was discovering principles that would reshape manufacturing across multiple industries. Assembly line techniques, prefabrication methods, and accelerated training programs developed for wartime shipbuilding would influence post-war production in sectors from construction to electronics. The emergency that forced innovation was creating methods that would define industrial practice for generations. November 8, 1942. Kaiser Shipyard No. 2 hummed with anticipation as workers prepared for something unprecedented in maritime history. The keel of SS Robert E. Peary was about to be laid, but this would be no ordinary Liberty ship construction. Kaiser had issued a challenge that seemed impossible even by his revolutionary standards. Build a complete cargo vessel in less than 5 days. Traditional shipbuilders called it a publicity stunt. German intelligence dismissed it as American propaganda. Neither understood what they were about to witness. The construction began at 12:01 a.m. with the laying of the keel, a massive steel backbone that would support the entire vessel. But unlike traditional construction, major hull sections were already taking shape in fabrication areas throughout the shipyard. Bow sections, stern assemblies, and deck plates had been prefabricated during previous weeks, waiting for their moment in final assembly. Workers moved with choreographed precision and following workflows perfected through months of revolutionary experimentation. By dawn of the first day, the ship's basic framework was visible. Massive cranes lifted prefabricated sections into position, while welders joined them with continuous beads of molten steel. The pace was breathtaking. Where traditional construction progressed in stages over months, Peary's assembly advanced in hours. Spectators gathered along the shipyard perimeter, watching in amazement as a cargo vessel took shape with mechanical efficiency. The second day brought installation of major systems. Engine components arrived on schedule, lifted by crane into position with millimeter precision. Electrical systems, plumbing, and ventilation were installed simultaneously by specialized teams working from detailed blueprints. Every component had been manufactured to exact specifications, eliminating the custom fitting that slowed traditional construction. The ship was growing not just in size but in complexity, gaining the mechanical systems that would power it across thousands of miles of ocean. Day 3 focused on completion of hull plating and superstructure assembly. Workers swarmed over the growing vessel, welding deck plates, installing bulkheads, and completing the bridge structure that would house navigation equipment. The welding work was particularly impressive, continuous seams that joined steel plates in joints stronger than the metal itself. Critics had predicted welded ships would split apart under stress, but Kaiser's vessels were proving more durable than traditionally riveted construction. The fourth day brought final systems installation and preparation for launch. Propellers were mounted, rudders installed, and all mechanical systems tested for functionality. The ship that had been nothing but drawings and raw materials less than 100 hours earlier was now a complete ocean-going vessel capable of carrying 10,000 tons of cargo across submarine-infested waters. Workers painted the hull, installed navigation equipment, and completed final inspections with meticulous attention to detail. At 3:30 p.m. on November 12th, exactly 4 days, 15 hours, and 29 minutes after construction began, SS Robert E. Peary slid down the launching ways into San Francisco Bay. Thousands of workers cheered as the vessel entered the water, their impossible achievement now floating reality. They had shattered every assumption about shipbuilding speed, proving that American industrial innovation could accomplish what traditional methods declared impossible. The launch sent shockwaves through maritime industries worldwide. Naval officers who had dismissed Kaiser's methods as publicity stunts now demanded detailed technical reports. British shipbuilders studied American techniques with newfound respect and growing urgency. Allied planners began recalculating tonnage war mathematics based on production rates that seemed to defy physical limitations. The news reached German naval headquarters in Berlin through intelligence channels that had previously provided reliable assessments of Allied capabilities. Initial reports were dismissed as American propaganda. No shipyard could possibly complete a cargo vessel in 4 days. Traditional construction required months of careful work by skilled craftsmen. The idea that semi-skilled workers could assemble an ocean-going vessel in less than a week challenged every assumption about maritime engineering. But confirmation arrived from multiple sources. Neutral observers in San Francisco Bay reported witnessing the launch. Intercepted American communications confirmed construction timelines that seemed impossible. Aerial reconnaissance photographs showed Kaiser shipyards operating at industrial intensity that dwarfed anything in German experience. The reports were accurate, and their implications were devastating for German Atlantic strategy. Admiral Karl Dönitz, architect of Germany's U-boat campaign, studied the intelligence reports with growing alarm. His submarine fleet had achieved remarkable success throughout 1942, sinking Allied vessels faster than traditional shipyards could replace them. The tonnage war appeared to be tilting decisively in Germany's favor. Now, suddenly, American production capacity had exploded beyond all calculations. The strategic foundation of the Atlantic campaign was collapsing. German naval planners had built their entire Atlantic strategy on carefully calculated assumptions about Allied production capacity. Their intelligence assessments were based on traditional shipbuilding methods, conventional construction timelines, and historic workforce limitations. These calculations had proven accurate for the first year of America's war involvement. Liberty ships took months to complete, just as German analysts predicted. Kaiser's revolution invalidated every assumption simultaneously. Construction times had collapsed from months to days. Workforce requirements had shifted from skilled craftsmen to semi-skilled industrial workers who could be trained in weeks. Production capacity had multiplied beyond anything German planners thought physically possible. The careful mathematics that justified U-boat strategy were suddenly meaningless. The implications rippled through German strategic planning with seismic intensity. If Americans could build ships in days rather than months, then U-boat destructive capacity would never achieve the sustained superiority necessary for victory. Germany was producing submarines at maximum industrial capacity, but that capacity was finite. American shipbuilding capacity appeared to be expanding exponentially, limited only by steel production and workforce recruitment. Dönitz requested immediate assessments of German U-boat production capabilities. Could submarine construction be accelerated to match American shipbuilding improvements? The answer was sobering. German submarine construction was already operating at peak efficiency. The complex engineering required for U-boat production could not be simplified like cargo ship assembly. Submarines demanded precision manufacturing that resisted mass production techniques. The strategic balance was inverting with mathematical inevitability. American shipyards were launching vessels faster than German submarines could sink them. Each passing month would widen the gap as Kaiser's techniques spread throughout Allied shipbuilding. The tonnage war that had seemed so promising in early 1942 was becoming a production contest that Germany could not possibly win. German intelligence had failed to anticipate the most crucial factor in America's industrial transformation: the willingness to abandon traditional methods entirely when circumstances demanded revolution. European military thinking was constrained by centuries of established practice and professional tradition. American industrial leaders approached wartime challenges with entrepreneurial flexibility that rendered conventional wisdom obsolete. The failure was not just tactical, but philosophical. German planners had studied American capabilities without understanding American adaptability. They had analyzed existing systems without anticipating systematic transformation. They had calculated current capacity without recognizing potential for revolutionary improvement. The intelligence failure that began with underestimating American shipbuilding would eventually contribute to losing the entire war. The numbers told a story that transformed the mathematics of global warfare. By the end of 1943, American shipyards were launching Liberty ships at a pace that defied comprehension. Kaiser's Richmond yards alone produced 519 Liberty ships, nearly 20% of total American production, in less than 4 years. The techniques pioneered for SS Robert E. Peary had spread throughout American shipbuilding with viral intensity, revolutionizing maritime construction from coast to coast. Total American ship production during World War II reached staggering proportions: 2,751 Liberty ships, over 700 tankers, more than 1,300 naval vessels, and hundreds of specialized craft. The industrial transformation that began with Henry Kaiser's revolutionary methods had created the largest shipbuilding program in human history. American yards were launching more tonnage in months than most nations produced in decades. The arsenal of democracy had become the shipyard of the world. The impact on the Battle of the Atlantic was immediate and decisive. By mid-1943, American shipyards were replacing sunk vessels faster than German U-boats could destroy them. The tonnage war that had favored Germany throughout 1942 was inverting with mathematical precision. Allied shipping losses, while still significant, were being overwhelmed by replacement production that seemed to accelerate monthly. Kaiser's methods had proven scalable beyond all original projections. Techniques developed for Liberty ships were applied to tankers, cargo vessels, and eventually warships. Training programs that created semi-skilled welders in weeks were expanded to produce thousands of maritime workers monthly. Assembly line principles that revolutionized one shipyard were implemented across America's entire shipbuilding industry with standardized efficiency. The human cost of this transformation was measured not just in lives saved by faster ship production, but in opportunities created for previously excluded workers. Women comprised nearly 20% of shipyard workers by 1943, performing jobs that had been exclusively male for generations. African Americans found employment in shipbuilding at unprecedented levels, contributing skills and dedication that helped power Allied victory. The Liberty ships themselves proved remarkably durable despite critics' predictions about welded construction. Of 2,751 vessels completed, only 200 were lost to enemy action, a survival rate that vindicated Kaiser's revolutionary methods. The ships that skeptics had dismissed as ugly ducklings carried over 70 million tons of cargo across submarine-infested waters, delivering the supplies that sustained Allied forces on every front. Individual Liberty ships compiled remarkable service records that testified to their engineering quality and construction durability. Many vessels survived multiple torpedo attacks, demonstrating that welded joints were actually stronger than traditional riveted construction. Ships that had been built in weeks served reliably for years, carrying cargo from Alaska to Africa, from Australia to Britain, wherever Allied forces needed supplies. The psychological impact extended far beyond production statistics. German U-boat commanders reported declining morale as their tactical successes failed to achieve strategic objectives. Sinking Allied vessels no longer guaranteed supply line disruption when replacement ships appeared faster than submarines could destroy them. The hunters were becoming the hunted as Allied anti-submarine warfare improved while German submarine production remained static. German strategic planning underwent fundamental revision as the implications of American industrial transformation became undeniable. Admiral Donitz's U-boat campaign, which had seemed so promising in early 1942, was failing to achieve its primary objective, strangling Allied supply lines through sustained destruction of merchant shipping. The tonnage war had become a production contest that Germany could not win. U-boat losses were mounting while replacement construction lagged far behind American shipbuilding acceleration. German submarine production peaked at approximately 40 vessels monthly, impressive by European standards, but inadequate to offset both combat losses and the exponential growth of Allied shipping capacity. Each passing month widened the gap between German destructive capability and American productive output. The strategic initiative in the Atlantic was shifting decisively toward the Allies. Improved convoy protection, Enhanced anti-submarine warfare techniques and expanding air coverage were making U-boat operations increasingly dangerous. Meanwhile, American shipyards were launching vessels at rates that transformed every tactical German success into a strategic failure. Sinking individual ships no longer mattered when shipyards produced replacements faster than submarines could destroy them. German intelligence failures compounded the strategic crisis. Naval planners had based their Atlantic campaign on assumptions about American capabilities that proved catastrophically wrong. The careful calculations that justified U-boat strategy were invalidated by industrial transformation that German analysts had failed to anticipate. Intelligence systems designed for traditional warfare proved inadequate for analyzing revolutionary industrial mobilization. The economic implications were equally devastating for German planning. Submarine construction required scarce materials, skilled workers, and sophisticated manufacturing facilities. Germany was already operating at maximum industrial capacity, with limited ability to expand production significantly. American shipbuilding, by contrast, was demonstrating apparently unlimited expansion potential as new shipyards opened and existing facilities increased output. By late 1943, the Battle of the Atlantic had effectively ended as a contest between construction and destruction. American production had achieved such overwhelming superiority that German submarine successes, while still tactically significant, could no longer achieve strategic objectives. The tonnage war that had threatened Allied survival was becoming a historical curiosity as Liberty ships flooded the Atlantic in unprecedented numbers. Individual U-boat commanders reported the psychological impact of facing seemingly unlimited Allied shipping. Veterans who had enjoyed remarkable success in 1942 found themselves confronting convoys that appeared to multiply despite sustained attacks. The mathematical inevitability of German defeat in the Atlantic became apparent to submarine crews long before official acknowledgement reached Berlin's strategic planners. The failure extended beyond immediate military consequences to fundamental questions about German strategic thinking. Nazi leadership had consistently underestimated Allied industrial potential, particularly American capacity for rapid transformation under wartime pressure. The same intelligence failures that miscalculated shipbuilding capacity would plague German planning in other theaters as American industrial might continue expanding. The Liberty ship program became a model for industrial mobilization that influenced manufacturing approaches across multi-sectors. Techniques developed for rapid shipbuilding were applied to aircraft production, munitions manufacturing, and military vehicle assembly. The revolution that began with Henry Kaiser's refusal to accept traditional limitations had created methods that would reshape American industry for generations. The strategic reversal in the Atlantic marked a turning point in global warfare. German forces would never again threaten Allied supply lines with the intensity achieved in 1942. The industrial transformation that produced Liberty ships in days instead of months had guaranteed that American productive capacity would ultimately overwhelm Axis military strength. The war's outcome was no longer in doubt. Only its duration remained uncertain. The story of American welders building ships in 4 days instead of months reveals something profound about human potential under extraordinary circumstances. When traditional methods proved inadequate for survival, ordinary people accomplished the extraordinary through innovation, determination, and collective effort. The Liberty ship program demonstrated that the impossible becomes possible when necessity meets imagination backed by unwavering commitment. Henry Kaiser's revolution succeeded because it challenged every assumption about how things had always been done. Traditional shipbuilding represented centuries of accumulated wisdom and proven techniques. Yet when traditional methods threatened Allied defeat, American industrial leaders chose innovation over tradition, speed over perfection, and revolutionary change over conventional practice. The results validated their courage to attempt the impossible. The human dimension remains the most remarkable aspect of this transformation. Farmers became welders, housewives operated cranes, and teenagers assembled engines for vessels they would never see again. Their collective achievement, building ships faster than enemies could sink them, helped determine the outcome of global warfare. Individual contributions multiplied into industrial transformation that changed the course of history. The intelligence failure that left German command ignorant of American capabilities illustrates the danger of assuming the future will resemble the past. Strategic planning based on static analysis of existing conditions proved catastrophically inadequate when those conditions underwent revolutionary transformation. The lesson applies beyond military affairs to any situation where established patterns face disruptive innovation. Perhaps most significantly, the Liberty Ship program proved that human ingenuity and industrial capacity, properly organized and motivated, can overcome seemingly insurmountable challenges. When the survival of democracy itself was at stake, Americans reinvented shipbuilding, revolutionized manufacturing, and demonstrated that free societies possess adaptive capabilities that authoritarian regimes consistently underestimate. The welders who joined steel plates in continuous beams stronger than the metal itself were doing more than building ships. They were forges, the tools of victory, creating the means of liberation, and proving that ordinary people can achieve extraordinary things when freedom itself hangs in the balance. Their legacy endures in every challenge that seems impossible until someone refuses to accept impossibility as final.